data. You cannot enter just like that whatever you want. It has to be logical. Like, for example, you're entering the country code here. So if you take this Benin, they have entered the code BEN, Benin. So they have taken logically like first three letters as a code. So it makes sense, right? So like that, instead of it is easy to recognize the country code if the first three letters is entered. Otherwise, if you enter some other letters, for example, you are entering 1, 2, 3 or something from other letters like ABC, does it make sense? It is not logical, right? Then also it will be difficult for you to recognize how to relate the code with the country name. It will be difficult for you only. So when in the schema, you always in the logical schema, the data has been entered in a logical way. That you need to keep in mind. Okay.
Yes, ma'am.
Now clear?
Yes, ma'am.
Yeah. And, if they ask for the ID to enter here, you need to enter your ID only. You are not going to enter your name. You are not going to enter your date of birth. If you enter that, then it is logically incorrect. Got it?
Yes, ma'am.
Yes. So we have seen how these relational models are distributed. It can be small scale, medium scale, and larger scales, which is cloud based. Next, we are jumping into this relational databases. So relational database, any idea?
We
Now,
stored the
only we
data
have
in the form of table.
we have spoke so much about the relationship between the tables, right? How does it look?
Ma'am, related to each other, ma'am.
Yes, very good.
One table is related to second table related to third table, ma'am.
Very good, very good. Yes, correct. So how does it look? Do you have any idea how does it look? So it is just going to look like a spreadsheet only, nothing. So see, table means spreadsheet only now, but it will be linked between each other. That's all. Simple. Okay. So it looks like a Excel sheet, and you are going to perform a SQL query language to query the data from the table. Okay, you are going to use the SQL language from there. Okay, so can anyone read this for me? What is relational database?
A relational database is a collection of data items that have predefined relationships between them.
Yes, as you said, so there will be the predefined relationship between them. Correct.
It requires a fixed definition of the structure of the data.
Very good. It required a fixed definition. What is relational database design then?
The relational database is often referred to as structured query language database. It is a collection of data items with predefined relationships. Tables are used to hold information about the object.
Very good. Yes, that's all. See, it is simple. The database, it is often referred to, as I said, it is we are going to use the structured query language, and it is also a collection of data items with predefined relationships, and tables are used to hold the information about your objects. Okay, this is the basics that you need to know. So the main reasons why we use this relational database is like so basically it is supporting the structural query language SQL, and it is also ensures that the data integrity, and it also supports the transactions. So that is why we are using this relational database. So see, when you do transaction, what happens? So if you take a money, it is deducting some amount of money, right? Next time when you again take money from the ATM, it already knows that some amount is like already detected. We need to detect from the see, you're withdrawing something around like 100 rupees. You have already 1,000 rupees in your account. You're withdrawing 100 rupees from your account, and what is the balance? So you'll be having 900 in your account. So again, you're withdrawing 100 rupees from your account. Then it has to show 800 rupees only. Again, it cannot show 900 now. It depends upon the previous transaction. Your money is deducted up to 900, and after 900 again deducted to 100. Again, it is giving you the text message of 800, right? There is a relationship between the transaction, correct? My voice is audible now?
Yes, ma'am.
Yes,
Okay.
ma'am.
So understood now the concept. So basically the data has the relation between one another. That is the main concept here. For that, you are going to use this SQL. That's all. This one, the use cases, we have the customer relationship management and business intelligence tools like finance reporting and data analysis. These are the use cases. And this thing you need to keep in mind. So these are all the questions you will be getting, like what are all the relational databases? Okay, in exam aspect, you need to remember all this. You need to know what is relational database and what is non-relational database. In relational database, we have only these types. Okay, MySQL, Amazon Aurora, PostGRE, and Microsoft SQL and Oracle. Okay, these are the types that we coming under the relational databases. Yes. So they have given some relational database examples here. Each table is organized in columns and rows, right? So what is column is called?
Field.
Yeah, very good. So this column holds a special kind of data, such as this column holds a special kind of data, such as numbers, strings, dates. This is strings, dates, nothing. There is no dates. Okay. So it can consist dates also. So and each in this row, there's a set of value depends on each other. Like so that the idea of this name is like 2, and the country code is they have given AFG again related to one another. Okay. Next, non-relational databases. So a relational database means we are using the SQL language, a structured query language. Related to each other. What is non-relational then? The name itself shows. What is non-relational?
MongoDB. MongoDB.
MongoDB. Okay.
Dynamo.
MongoDB, is it a non-relational?
Yes, ma'am.
Yes, ma'am.
Okay. See, non-relational, there is no relational between the databases. That is simple logic. Yes, no SQL. No SQL. non-SQL, non-relational. Everything is same. Okay, no SQL, non-SQL, non-relational databases. You need to remember this. Okay. So no SQL, non-relational databases. These are like built. See, you need to read this, please. Yeah, some of you. Can anyone read this for me?
A non-relational database is a database that does not follow the relation model. Non-relational databases do not require a fixed definition of the structure of the data. In non-relational database design, a non-relational database, which is often referred to as a NoSQL database, is a database that does not use a table structure to store data.
Yes. No non-relational database. So it is purposely built for a specific data models, and it have some flexible schemas for modern building applications. Okay. So the main benefits of using this non-relational databases is like we have flexibility, scalability, and it is highly high performance and highly functional. Okay, that is why we are mainly using non-relational databases. Okay, so main example for this non-relational database, I think they have given. Okay, they have given C, JavaScript. And this is the main example for the non-relational database. Here we are not going to use any kind of tables, but JSON is the main example. JSON, you all know, right? JavaScript object notation. Obviously, you would have known
Ma'am,
that.
it is easily accessible also, non-relational database.
Yes, very good. So, as you already know, so the JSON is the non-relational database type. Okay. They have the use cases they have given. It is basically used for fraud. Some fraudulent is happening means it will deduct, and for Internet of Things and social networks, they are using this non-relational databases. So again, you are going to keep all this. Yes, as you said, MongoDB is there in the non-relational database. Correct. So keep everything in mind. Amazon DynamoDB, Amazon Redshift, MongoDB, and Apache HBase. All these things comes under the non-relational database. What are the relational database? Can anyone sums up? I told you to remember.
Ma'am, please repeat that what you said.
Yes, I was telling relational database. We will be having some kind of examples in relational database and also non-relational databases. You need to remember this in exam aspect. Okay. For non-relational databases, we have DynamoDB, Redshift, MongoDB, and Apache HBase. And for relational databases, we have MySQL, Amazon Aurora, PostgRE, Microsoft Server, and Oracle. Okay, you need to remember this for exam aspect. Okay, they'll be testing you on what is relational database. Okay, so you need to remember all this. Again, for non-relational databases, we have some examples. Okay, you need to remember all this. Yeah. Can anyone read pros and cons of the relational and non-relational databases for me?
Relational
Pros
data.
and
Yeah, one by one, please. Someone read relational database, someone read non-relational. Anyone.
okay, ma'am. Pros and cons of relational and non-relational database. Relational database SQL pros no and reliable technology, easy to write complex queries, well-known SQL language, well-supported transactions. Cons use vertical scaling and include a fixed schema.
Very good. So understood now? These are the pros and cons. Coming to the non-relational databases, who is going to read? Yes, please read.
Non-relation database pros flexible schema, good fit for storing and retrieving fast massive accounts of data of different types. Horizontal scaling, good fit for hierarchical data. Cons are a relatively new technology, do not guarantee data integrity, is not good fit for complex queries for a transactional application.
So it is not basically good. It's not a good fit for a complex queries or transactional applications. For transactional applications, we are only using relational databases only. We are not using non-relational databases. Then we will be rich, right? We are using non-relational. So hope you all understood this slide and moving to the next. We have database design and anomalies. Before seeing this topic, can we have a break of 15 minutes? Is are you all awake or slept off? Guys, do you need a break?
Yes, ma'am.
Okay then. We will come back at 4:15 and we will see the rest. Thank you. Everyone back? Can we start?
Yes, ma'am.
Okay. So, before break, we were talking about anomalies, right? So, what is anomalies? Anomalies as a word in general term, I would say that is anything that getting deviated from the standard process, which is known as anomalies. Okay, if something some constraint is set up for the thing, so if it is getting deviated for some other thing, then it is known as the anomaly. In database also we have such kind of anomalies like we have three different kind of anomalies. Let us see what is that. So before that, I think the well-designed database, how the well-designed database has to be. It has to be clear, as you all know that anything that has to be clear is the well-designed thing, right? And you need to check is the data your database is clean and consistent, okay? And is your database contains any all of the data and structure necessary, it is fulfilling your purpose. You need to check that. You need to check all the essential parts have been fulfilled in your databases, and you're going to check uh, is it cooperative or not with integrate well with other programs. Okay, you're going to check that, and also you're going to check the efficiency, how quickly is the user able to perform the work. Okay, you are going to check that, and so you're also going to check how accurate is your databases. Okay, so and it also has to be flexible and reusable. So you need to check all these things when you are designing your database. Then that is a good design. When it is fulfilling all these kind of aspects, that is a good designed, well-designed database. Okay, so let us see the three types of anomalies, which is quite interesting. So we have insertion anomaly and update anomaly and deletion anomaly. Let us see what it is. Like, can anyone read this? I will explain what it is. Yeah.
Insertion anomaly occurs when you cannot insert important data into the databases because other data is missing. For example, a clerk cannot add customer information for a new customer who has not made a purchase.
Good. So you understood, right? Like what is insertion anomaly? So they have given a clear example. A clerk is entering some information in the table, but he is not able to enter the customer's information for a new customer. Why it is happening? Because he didn't do any purchase, so he is not able to add that information of the customer. He can add the information of the customer only when he does the purchase. So these kind of anomalies happen, which is known as the insertion anomaly. Okay. So next we have update anomaly. Yes, please proceed.
Occur when data is stored redundantly within the same table. This anomaly make it difficult to ensure that all copies of a particular information value are updated when the value must be changed.
Yes, update anomaly is something like, see, if you are entering more and more data, the data has to be very much accurate. You cannot just like that add more and more data and keep on dumping up with all the informations, right? So it makes it difficult to ensure all the copies of that particular information. Uh, see, when you want to change the value, you need to change that value only. You cannot keep on loading up the table. So at that point of time, that update anomaly will be happening. Okay. So next we have deletion anomaly.
Occurs when you delete unwanted information, but the action also results in deleting information that you want to keep.
So this kind of anomaly happens when you're deleting that you don't want. See, okay, but what happens? It also delete the information that you want to keep. So this is known as the deletion anomaly. Okay. So for example, so what I will tell, like, so if suppose the the sale is cancelled and all the records of that sale is deleted. So then these type of anomaly is known as deletion anomaly. See, during the sale, you want to delete some anomaly, but all kind of sale, whatever you wanted to keep what kind of information you wanted to keep also, it is getting deleted. The other information also getting deleted, which is known as the deletion anomaly. But what you wanted to do? You wanted to delete only the information about the sale, but it is also getting deleted. It is also deleting the other information that you want to keep. Whatever the information you stored previously, that is also getting deleted, which is known as the deletion anomaly. Okay. Now we are clear now. So we have an activity based on these anomalies. We have a table. So they have given some it is not a well-designed table. It is a table with anomalies. So you are going to basically redesign this table. I will give you another 10 minutes to redesign the table. So once you are done, just keep the screenshot in the WhatsApp group. Okay. I just want you to redesign the table. Either you can write it in the notebook and take a picture and post it in the WhatsApp group. Anything is fine. Okay. But I want you to redesign this table using the anomaly concept. In it, you're going to find out what anomaly has happened in this table and how you're going to redesign this table. Okay. I will give you 10 to 15 minutes to think about this and redesign the concept and post it in the WhatsApp. Clear? Guys, are you there?
Yes, ma'am.
Understood, no?
Yes, ma'am.
Okay. Okay, start redesigning them. At 4, now it is 4:25. At 4:35 to 4:40, around 4:40, you're going to post the redesigned table in the WhatsApp group. Okay? Give me the answer, thumbs up if you understood what I said. No one understood what I said. Guys, did you understood what I said?
Yes, ma'am. Redesigning the table
Okay,
in the
thank
proper
you.
format or
Yeah, thank you. So I just wanted to make sure if you guys got my point and doing and working on the thing. Yes.
and basically we just have to arrange in the proper manner.
Yes. Basically, you have to arrange in the proper way and redesign the table. It can be in any schema, like however you wanted to design, but it has to be logical. Yes. But when you see that table, what is given with the anomaly, it is not logical and there are so many errors in that. You are going to redesign and post it in the WhatsApp. Okay. Yeah, well, if you are completed, I'm expecting you to post on the WhatsApp group. Done? Or still you need time?
Finish time.
Okay. Okay, let me know just when you're done. Okay, guys, if it is taking time, you can post tomorrow as well, no issues. Prepare it today, by today evening, and post it tomorrow as well. I'll coming tomorrow, be ready with the redesign table. Okay, I'll be asking for. It's okay. Can we move on to the next?
Yes, ma'am.
Okay. Yes, let us see database management system, DBMS, which is very important. So, what is DBMS? The definition of DBMS is database management system, as the name suggests. So, it is going to manage your data, right? So, how do you manage your stored data? Using DBMS only, right? So, by using this DBMS, we are going to manage all the stored data, okay? Which is known as DBAS, database as a service. DBMS is also known as the database as a service. Okay, it is used mainly for creating the databases. Okay, they have given some explanations about DBMS, and they have also given the two variations of databases. So mainly, this DBMS is used for like creating databases and inserting the data into a database, and they are going to whenever you want to store, retrieve, or update, or anything that you wanted to delete, you are going to use the, in a database. You are going to use the database management system, and you are going to perform. Okay, so this database management system, basically it is going to provide some tool to make all these activities about your data. Okay, so basically a company can design and model a database in the DBMS, okay, and run any command to manage that data. Okay, it gives also the users interface between the data in a database and the software. Okay, so this is known as a database. So we have two variations in this. One is single user, and the other one is the multiple user. In single user, like Microsoft Access is known as the single user, and we have in multiple users MySQL, Microsoft SQL, Oracle. Everything comes under this multiple user kind of categories. Okay, can anyone read this? What is DBMS? Am I audible? Are you there? Yes, can anyone read this for me? Am I audible or not? Guys, please respond. Am I audible?
Yes, ma'am.
Yes, someone please read the slide. Are you guys working on the designing of the table?
A DBMS is a software or database as a service that provides database functionality. It is used mainly for the following: creating databases, inserting data into databases, storing, retrieving, updating, or deleting data in our databases. The following is the primary benefit: reduces the cost of installing and maintaining servers. Two variations of DBMS are single-user DBMS applications such as Microsoft Access, multiple-user DBMS applications such as Oracle Database, Microsoft SQL Server, MySQL, and IBM DB2.
Very good. Thank you so much. Yes. So basically, this database management system, it is very helpful when it is coming to the cost criteria. So it reduces the cost that we don't have to set up any servers to maintain all the data. Installing and maintaining the servers is the biggest task when it's coming to the cost aspect, and it reduces the cost. Okay, that is why we are using database management system. So either it can be your data can be stored in the on premises, or it can be in the cloud. So this is the thing they have mentioned it here. This is the on premises where all your data is stored in your computers and networks in the organization, and this is the virtual data center in which where you can store all your data, which is located outside of the organization. Okay. So these are the two types of storage that we have. Okay. So they have given database as a service. Some key points about cloud-based databases. Yes, please. Someone read this, please.
A few key points about cloud-basic databases are hosted by third-party providers. These database servers are hosted in third-party data centers and accessed over the internet, the cloud, instead of being hosted on a local network. Second is reduced cost. These databases reduce the cost of installing and maintaining server. Third one is are fully managed. For example, with some AWS databases, you do not need to manage database management tasks such as server provisioning, patching, setup, configuration, backups, or recovery. Fourth is are faster. With these databases, you can use services such as AWS, which offer large amount of storage and processing power in their data centers.
Yes, mainly, so it is fully managed service which is offered by the AWS. So you don't have to manage any servers, that you don't have to provision any server, or you don't have to do anything at all. Everything will be ready-madely available in the AWS, and you are just going to store all your data over there, and you are going to access it using the SQL query language. That is what we are going to do. Simple as that. And also main benefit, as we have seen, it is reduces the cost much better, and it is very much faster, and it is also hosted by the third party providers. Okay. So next, they have given some database as a service examples as Amazon RDS, Amazon Aurora, Amazon DynamoDB. We will see about this in detail in upcoming sessions. Okay. So now just see what is like Amazon RDS means it Amazon Relational Database Service, as you all know. And they have given it manages the common relational database administrative task. And Aurora is again the fully managed RDS, relational database engine, and DynamoDB is also a fully managed, but it is a no SQL database. Okay. So you need to keep that in mind. DynamoDB is a no SQL database. You cannot use this DynamoDB for the transactions. Okay. Next, we are almost at the end of the session. So we have some checkpoint questions. I would like to all of you to switch on the camera and answer these questions. Yes, please. Which type of database is often referred to as SQL database? Could you all please switch on the camera? Yes. So what about others? Yes, guys, so hope you all understood the theory behind the database. My voice is audible, right?
Yes, ma'am.
Okay. So I have posted a question. So could you please answer that?
Ma'am, a relational database.
Relational database.
I'm relational.
Okay. Have you seen that answers? No, right? Okay. What is the purpose of DBMS?
To manage the data.
To manage the
Yes, correct. So that it basically provides you the functionality, right? So you should keep that in mind. And also we have one component of a database. They are asking name one component of a database. Any one component. So I in the beginning I have told some keywords, right? Do you remember that? Keywords, key terms. So, could you remember?
Schema.
Yeah, could you remember recollecting that?
Data. Data model.
Data model.
Schema.
Schema. Very good. Yes, that is one name one component of database. That is the answer for that. And name two of the key traits. So I have taught you key traits for the well-designed database. Can anyone remember and tell me? Key traits. First of all, data has to be clear. I taught you, no? Can anyone remember? That's okay. So yes, just go through the slides once today, okay, in the evening. And this is just a theory now. Just go through the slides for the detailed theory part and everything. And you will understand. I hope you all understood the session very well. If yes, please give me the thumbs up. Can we do Casey also? You want?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
You are going to answer. I'll just mark the answer. Like whatever you say, I'll mark it. Okay. Yes. What is database?
Third one.
Third one. Sure. Everyone else?
I'm third one only.
Okay.
Yes, ma'am.
Which database attributes accurately represent elements of a relational database? Select two.
First and third.
Yes.
Yes, ma'am.
Yes.
First.
First and third.
Sure. What are the primary features of NoSQL database?
first and third.
And first and third.
First and
Third,
Third.
ma'am.
which of the following is not a type of anomaly?
First.
Structure.
Good.
First one.
What is the primary benefit of using database as a service? Primary benefit.
Last one.
Very good. All correct. Well done, guys. This shows that you have understood. Okay, let's go for the next case then. We have another. I think this case we can do only after the slide. Maybe we can do this tomorrow. Okay, you just do that anomaly table redesign. Okay, for today, when coming back, we will check on that tomorrow. Okay.
Okay, ma'am.
Okay, guys. Then thank you for the day. Thanks for listening to the class.
Yeah.
Thank you, ma'am.
Bye bye.
Thank you, ma'am. Thank you, ma'am.
Okay, guys. Tell me if you don't understand anything, just ask me. I'll clear the doubts. Okay.
Yes, ma'am.
I hope you all understood, right? Please give me the thumbs up.
Yes, ma'am.
Yes, ma'am.
Thank you. Thank you so much. Yes, guys. Then we will wrap up. Bye. Take care. Bina, are you there? You wanted to say something? I'm just ending the session. Okay, then I'll end the session now. Okay, bye, guys.